Namaskar and a warm good morning to all of you. This presentation deals with the Q style relays and the type of relays which are used in railway signaling system. This is introductory slide. These are the Q style relays about which we will be discussing. While this is a polarized relay and this is a K50 type relay, metal to metal contact, which presently we are not going to discuss. Coming to the basics of relays, let us start with the basic relay, that is QN1 relay. This QN1 relay working voltage is 24 volts, while the coil resistance I have taken roughly as 400 ohms for a 24 volts relay. It depends on from relay to relay. Here you can see this relay being shown is having a resistance of 345 ohms. If the coil resistance is 400 ohms, and the working operating current will be 60 milliamps, while the minimum pickup voltage is 19.2 volts. This minimum pickup voltage is voltage required for picking up the relay, while the pickup time is 150 milliseconds. What is this pickup time? Once you give supply to the coils, the amount of time required for the front contact to make is 150 milliseconds, while drop away time is 20 milliseconds. The the relays have different combinations. Generally used are 12F 4B or 8F 8B type of relays. There are other combinations also, and generally these two relays are used. Application: this relay is used for all circuits which in internally, that is especially if you take in RE area, only internal relays are used as QN1 relays, while in non-RE area this relay can be used even for internal and external circuits also. Another type of relay is QNN1 relay. This is a DC twin neutral rain relay. This is just on par with the previous relay, QN1 relay. The only difference is that in one unit you have two different relays. One unit is split into two different relays. This is generally used to minimize the place required and used where the number of contacts required are very less. As it is, the normal working voltage is also 24 volts, 470 ohms. The contact resistance, the combination is generally 6F2B or 4F4B type. So this is a two neutral relays with a common heel piece and a common base. So the heel piece that is available is common, but the armatures, you can see the armatures are here. These are different, but the heel piece जो पीछे रहती है ना, that is common. The armatures, the lifting slots, all are different. That is two different relays. This can be used in place of QN1 relays where number of contacts required are less. Now let us discuss about another relay, QNA1. This is Q series neutral AC immunized DC neutral line relay. AC immunization is relay in this relay is achieved by provision of a copper slug. This is the copper slug, and providing this we have made the relay AC immunized. If AC immunization means even if AC supply is given to the relay will not have any effect. Copper slug provided at the armature end of the core. So this is the armature end and the copper slug is provided here. No magnetic shunt is used in this relay. In all other aspects it is just the same as a QN1 relay which we discussed earlier. While the AC immunity level for this relay is 200 120 volts AC. Here there are another 2 points that I would like to tell. First one, at 120 volts AC, when you give this supply, there will not be any change in the relay. While up to 300 volts AC, the relay may have small turbulence, but the back contact will not make. While up to 1000 volts AC, the front contact will not make. Means at 1000 volts AC, back contact may break, but front contact will not make. Now, applications. All external circuits we can use this QNA1 relay. All external circuits for detection circuits, HR, HPRs, DPRs, which are used connected in the location box, or NWKRs, RWKRs, which come into the relay room. They are connected with this QNA1 relay. QNA1K. This is also almost on par with QNA1 relay, but the only difference is the resistance is 1000 ohms. In all other aspects, it is just like QNA1 relay, while AC unit is also just like the previous relay. Voltage 24 volts. The current here is 24 milliamps. This is the main difference. So when the resistance is 1000 ohms, the current is 24 milliamps only. Because of this, this relay is used at places where the current required may come down. For example, HR circuit. In HR circuit, this is used for HR relay, where HR relay will picks up after many, about 30 to 40 contacts. So in such conditions, the droppage of voltage will be less and the current will also come down because of resistance of all the contacts in series. In that condition, for example HR, we use this type of relay. This is also used in relays in circuits where the relay is picked up through PCBs. For example, we use this relay in SSBPAC, or in um, SSDAC, single section digital axial counters. Also we use these relays for VR and PR. All circuits, this way the application, all circuits where number of contacts in the circuit are more than 45. So this also used in circuit in in WJR as point circuit, WJR relay, as said VR and PR in SSDAC. The next relay will be as QS3 or QSA3. The only difference QS3 and QSA3 is QSA3 is again AC immunized. This is a sensitive line relay, which is working voltage is 12 volts DC, with a resistance of 1000 ohms. Now the usage of QSA3 relay is very less. Previously we used to use this in axial counter, that is for EVR and SUPR relays. QB3. This is DC biased neutral line relay. This is also non-AC immunized. The rated voltage is 12 volts DC and current is 60 milliamps. So what are the features of this QB3 relay? It operates only when rated DC supply of correct polarity is connected. When I use the word B, biased, means correct polarity, R1 positive, R2 negative, then only the relay will pick up. If you give opposite, the relay will not pick up. Biasing is achieved by provision of permanent magnet which aids in the electromagnetic flux. Armature gets attracted only when both fluxes, here the electromagnetic flux and the permanent magnetic flux, are acting in the same direction. So here two fluxes are available. One flux is achieved when we give supply to the coil, while the other one is because of the permanent magnet. These two shall be available for the relay to pick up. The main advantage is that two relays can be connected on the same line, thus saving a pair of Lyle conductors. Here the application part, this is used in the single line tokenless block instrument for the relays CRR R and CRR N. So one relay, one pair of line is used if this relay is available, and we can pick up two different relays in one pair. That is the main advantage of this QB3 relay. Similarly, QBA1 relay is also of the same type, but the only difference is this is AC immunized, and for AC immunization we have a copper slug, while for biasing we have a permanent magnet. These are the special parts of this relay. The Coil resistance is 200 ohms. The working voltage is 24 volts with AC immunity 120 volts AC. Current rating is 3 amps, which is continuous, while switching is 2 amps for the contacts. What are the features of this QBA1 relay? So it operates when DC voltage of correct polarity is connected, as same as QBA relay, QB1 relay. Positive R1 should be given and negative R2 should be given. Copper slick is provided at its armature end to make it relay AC immunized, while biasing feature is achieved by providing a permanent magnet. This relay is generally used in diodo block instrument for the relays BLR and NR. Again, the reason is same. We have only one pair between two block instruments, and that pair is used for picking up BLR and NR. Once one polarity, for one polarity BLR will pick up, while the other polarity in reverse NR will pick up. If this relay is not available, then we need to have provided two separate line wires between the block instruments, which is a very costly affair. QBCA relay. This is a Q series biased AC immunized relay with heavy duty front contact. Now the construction features are, the construction is similar to the previous QB-A1 relay, but it has two heavy duty front contacts and four back contacts. So here you can see the heavy duty front contacts which are available, and these are all the back contacts. The front contacts can carry and switch up to 30 amps current at 110 volts DC. This is the reason why we use it for point operation. Copper slug for AC immunization, permanent magnet adjacent to the copper slug for biasing feature. So AC immunization, copper slug, and biasing feature, permanent magnet is used. Apart from this, we have one part called blowout magnets inside. These are called the blowout magnets, which are used to quench the any type of spark that is available during operation. This helps in making the contact properly, and thus any contact will not become defective. This is generally used in many places, that includes a point operation, gate control operation, or in any circuit where current required is more. Here you can see the specialty. The two extension springs each beside the base are joined with front contacts. So like this, these are joined front contacts. So C1 and C2 is actually one contact. C7, C8 is one contact. C3, C4 is one, while C5, C6 is one. The minimum pressure for the front contact here is 56 grams. Generally, for normally it is only 28 grams. For this relay it is 56 grams. One more important thing is, here you see C1, C2 should be incoming, while C3, C4 shall be outgoing, while C7, C8 shall be incoming for the negative side, while C5, C6 should be outgoing for the negative side. This is mandatory because if you provide your wiring in this way, the blowout magnets work properly and your relay will not, contacts will not get burnt or soldered. Now coming to the next relay, QSPA1 relay, slow to pick up AC immunized DC neutral line relay. Working voltage is 24 volts, coil resistance 208 ohms, while contact resistance 8F 84B. AC immunity level is 300 volts AC. While the pickup, again the same thing, AC voltage is 300 volts AC, as I have previously described in for AC immunity relay, 120, 300 and 1000. What are the differences? I have told you. So in general you can say 300 volts AC even for this relay, or QN A1 relay also. Pickup time here, this is important, 540 to 600 milliseconds, while release time is 140 to 200 milliseconds. How this is achieved, how we are able to pick up this relay slowly? This is provided with the help of a magnetic shunt at the armature end. the magnetic shunt at the armature and make the relay slow to pick up. So this is your armature, and this is the magnetic shunt, because of which your relay is made to slow to release. While this is your copper slug at the heel piece end to make the relay AC immunized. This is very important relay, and this is relay is used as TPR, the first repeater relay for any track relay. We use this especially for track relays to pick up slowly. The reason is, in case there is any RE wire cutting and fall on the track circuit. Let us imagine there is a train occupied on the track, and the OHE wire is cut and falls on the track. Heavy current will be induced, and the voltage, that current and voltage is likely to go into your track relay. Your track relay is AC immunized for only 50 volts AC. Hence your relay can pick up, the track relay can pick up. While if the track relay picks up, naturally your TPR also will pick up. But here the TPR is made slow by 600 milliseconds. So what will happen? Your TR has picked up. Before your TPR picks up, your OHE will trip for 300 milliseconds. So even though your TR has, here the train is in occupied condition, track is in occupied condition, and your TR is picked up, which is unsafe. To make it safe, to make it in such a way that there is no effect of that, we are using this QSPA1 relay. Apart from that, we have other benefits also by using QSPA1 relay. The routes will not be held because of this feature. Proper sequential operation is required for route releasing. QSRA1 relay, it is working voltage is 24 volts, while coil resistance is 208 ohms. AC immunity 300 volts, drop away 260 milliseconds. So what are the features? Magnetic shunt is provided at the heel piece end to make the relay slow to release. So magnetic shunt is provided at the heel piece end. This is your heel piece end, and your magnetic shunt is provided at the heel piece end. For making it slow to pick up, it is provided at the armature end, while for slow to release, it is provided at the heel piece end. And a copper slug is also provided for AC immunization. This is application is used as HPR and DPR relays in RE area, so that momentary track drop, if there is any momentary track drop or momentary voltage drop for HPR and DPR, the relay will take time to drop. Thus, fluctuation of your aspects will be avoided. QL1 is a Q series magnetic latch relay, which working voltage is 24 volts. Here there are two coils, reverse coil 145 ohms and release coil 680 ohms, which is provided inside this coil one over the other. The contact combinations generally are 8F6B, 11F4B. It is used as per requirement. What are the basic features? Relay latches magnetically in the operated position. The best thing is, once the relay is picked up, the voltage is not required to keep it in picked up condition. It is achieved by use of a permanent magnet provided at the heel piece end. So here we have a permanent magnet provided at the, this is your heel piece, this is the permanent magnet. With this we are able to hold the armature in the picked up condition. The other difference is there is no residual pin for this relay. For all other relays you have a residual pin, that is a small gap will be there between these two. But for this relay there will not be any gap. Heel piece is not provided in this relay. Going further about QL1 relay, the latch relay feed is cut off as soon as it is latched. So this is the circuit. You can see this is LR and this is LPR. This is used as an economizer contact. So the supply is coming like this through the drop contact of LPR, and your relay LR is picked up. Once LR is picked up, through this LR front contact, LPR is picked up. Now you can observe once LPR picked up, this contact is not available, but your LR relay is in still in picked up condition only, because it is now in latched and holds through magnet. This is the specialty. This relay, this contact is used to see that the current is not required to be given. This is saving the power supply. Similarly, to this is for pickup contact, while this coil is used for drop contact. So when you want to drop the relay, again you have to feed the supply. Here you can see in the negative side, LR front contact is used for holding it in this way for the release. So when I give supply through this front contact, this relay will drop. So this actually is this contact. Once the relay is dropped, this contact is not available, and the feed to the coil is opened. Thus, just to pick up and drop, we require voltage for that fraction of a second. After that, no supply is required. This nowadays is used in many places. This is having wide importance. Now point operation is given through QL1 relays. This is also used in modern signaling systems like UFSBI, SSDAC, and other such equipments. Even in EI we are using this. The main reason is to know the last operated position of the relay, even if the EI, SSB, PAC are shut down. With this, I end this Q style relays. Thank you. Jai Hind.